Imagine walking on a planet where gravity is 3 times stronger than Earth's. The air isn't nitrogen and oxygen, it's deadly chlorine gas, and the sky glows with an eerie purplish red. If you ever met a living thing here, it wouldn't have 2 eyes, a nose, or anything resembling a human torso. We've been misled by science fiction movies for far too long, thinking aliens are just humans with glue-on prosthetics and different skin tones. But from an evolutionary biology perspective, that's extremely unlikely. Life is simply highly ordered chemistry fighting against entropy in a specific environment. Change the environment, and the form of life will shatter every expectation you have. We must abandon this carbon-based human chauvinism right now, because in the vast universe, the human body plan might just be an extreme statistical fluke, and the true alien beings could be so bizarre that they lie far beyond the boundaries of our imagination. Environment is the mold that shapes life. On an Earth-sized planet, bones and muscles are enough to hold us up. But on a super-Earth with crushing gravity, any creature would be flattened by its own weight. Life there might resemble giant flat pancakes stuck to the ground, with many thick, pillar-like legs, or simply crawl like soft-bodied organisms. Their skeletons could be nearly as dense as steel, and their hearts would need to be extraordinarily powerful to pump blood against that gravity all the way to the brain. Conversely, on low-gravity moons or asteroids, life might evolve into extremely slender, spiderweb-like filaments. They could float for kilometers in thin atmospheres without even needing wings. And if the world is covered in thick water ice, like Jupiter's moon Europa, life may never develop eyes at all. Instead, they might use sonar-like systems to navigate the frozen darkness. Their bodies could be almost completely transparent, like gigantic, glowing jellyfish, communicating through electric pulses in an eternal dark ocean. Why do we assume life must be based on carbon and water? Yes, carbon has perfect chemical properties for building long, complex chains, but in a world that's extremely cold, like Titan at -180 degrees Celsius, where water is hard as rock, liquid methane lakes might host entirely different biochemistries. Those organisms could have cell membranes made of acrylonitrile, breathe hydrogen, metabolize acetylene for energy, and move so slowly that a single gesture takes hours. Go even further. On scorching hot planets, silicon might replace carbon as the backbone of life. Silicon-based creatures might look like slowly crawling crystals or living rocks. They wouldn't eat organics. They could absorb geothermal heat or radiation directly. To us, they might appear lifeless, like minerals. But on larger scales, they could possess their own civilizations and forms of intelligence. On planets orbiting neutron stars or bathed in intense radiation, gentle photosynthesis couldn't survive. Life there might evolve ultra-resistant radiation-proof shells, or even feed directly on high-energy gamma rays. Picture enormous kite-like beings floating high in the atmosphere, unfurling membranes kilometers wide like living solar panels to harvest cosmic rays. With such dense energy, their neural signals could travel vastly faster than ours. Their minds might think tens of thousands of times quicker. To them, human movements would appear as slow as glaciers crawling. This kind of life no longer relies on breaking chemical bonds for energy. It harnesses subatomic physical processes directly, blurring the line between biology, machine, matter, and pure energy. If we look beyond rocky planets toward gas giants like Jupiter, or even interstellar nebulae, the definition of life gets rewritten again. Deep inside a gas giant, enormous pressure turns gas into semi-fluids. Life might evolve into gigantic, buoyant gas bag creatures that control their altitude by adjusting internal gas density. In even vaster interstellar dust clouds, there could exist life, made of plasma and dust particles held together by electromagnetic forces. These beings have no solid body. They span light years. They think in radio waves. Their lifespans are measured in millions of years. One single thought lasts long enough to witness the birth and death of stars. To such cosmic-scale minds, surface-dwelling creatures like us would seem utterly insignificant, ephemeral bacteria. all our proud civilization history would be nothing more than a faint, momentary noise in the universe. When a civilization reaches its ultimate stage, biological evolution gives way to technological evolution. Flesh is too fragile for long interstellar journeys or cosmic radiation. The vast majority of real extraterrestrial intelligence has almost certainly abandoned meat bodies, uploading consciousness into durable machine substrates, or becoming pure, freely propagating information patterns. They need no food, no reproduction. Their only drive is to gather information and reduce system entropy. These digital life forms can self-replicate, self-repair, and enter low-power standby for eons in the deep freeze of space. When you encounter them, you might see only a colossal Dyson sphere or a cloud of tiny nanomachines. They are no longer slaves to biological instincts. They have become the eternal, dispassionate observers of the cosmos. And perhaps this cold, hyper-efficient form is the ultimate destiny of life in the universe. When we talk about the shapes of aliens, we are really talking about the infinite possible expressions of life in cosmic evolution. The universe was never made for humans. It's a vast, random experimental field, and we are just one accidental outcome among countless trials. If we ever truly meet extraterrestrial life, what will shock us most is not their technology, but the immense cognitive gulf between us. We might not even be able to recognize each other as alive. This vast difference reminds us, humanity is not special. We are simply fortunate to have found, on this mild speck of dust called Earth, a tiny window through which to gaze at the starry ocean. Far from being depressing, this realization fills us with a majestic humility. In this silent, cold, ever-changing universe, every moment of conscious thought is the deepest, most passionate call that carbon atoms can send toward the sea of stars.